Okay, good morning, everyone. It's 8:40, so I'm starting. Welcome again. Today, we will dealing more about modeling examples, all right? I'm assuming you all get the heck off the piazza. You've did your first homework. There will be another thing today, too, so there's a discussion going on in Piazza. I suggest you get involved with that too, all right? So today's first example, okay, let me wait a couple of more minutes so that everybody settles down. All right. Our first example this morning is called transportation problem. Well, the generalized version is a transportation problem. Let's read the problem together. Now we have two power plants, okay, generating electricity, and we have three factories that need electricity from those power plants, okay? So PP1 and PP2 represents my power plants, all right? And factory 1, factory 2, and factory 3 represents my factories, all right? Of course, each power plant has a different capacity. And in my example, the first one's capacity is 1,250. And the second power plant's capacity is 2,000, all right? My factories, each one requires a different amount. And the required amounts are written on there. So I have two plants, three factories. Okay. Apparently, I'm going to send the electricity from these power plants to those factories, right? But of course, I need a metric. What am I going to optimize? What is my performance measure? It's coming. Of course, there's the cost for us to transmit the electricity from some place to another, right? So in this example, well, we all have our supplies and demands, and we need to get the best costly transportation option, all right? So the numbers in here is given like that. For example, from power plant 1 to factory 1, per megawatt, it costs $50, all right? For factory 1, if I got it from power plant 2, it's $30. Apparently, factory 1 is closer to power plant 2. Everybody is closer to power plant 2. Power plant 1 is more expensive for all those factories. But it doesn't have to be like that all the time. This is the data, all right? So but the problem is then, I have electricity in those power plants, and those electricity needs to be transmitted to my factories. And what is my performance measure? I want to minimize the total cost. Okay? So how to satisfy the demand of each factory from the power plants with minimum total cost. Yeah? Okay. How about now? Come on, work. All right. Tell me the decision variables. What do you think an appropriate decision variable is? Decision variables. All right. Any idea? What do you think? Yeah. 6 decision variables. Good.
Like for the factory one, each from power plant one.
Okay. This is the, it doesn't, this is how let me change the color. It doesn't show that well. All right. This is how we represent it actually. Let Xij, I can do this like this. All right. Let Xij, number of megawatts, okay, of electricity from power plant I to factory J. in this case, you have to tell where I is coming from. So I is 1 or 2, and your J's can be 1, 2, and 3. Yeah? I just defined my variables. Xij, amount of electricity sent from power plant I to factory J. Clear? Now with this variable definition, we're going to formulate the model. Okay, so let's remember our Xij in here. It's from I to J, all right? Now let's write the formulation. For example, cost, minimize what? I started, minimize 50. What do I multiply 50 with? Yeah. So 50 is multiplied with what? You're supposed to say that. What is the variable for that? X? Exactly. Minimize x11 plus. What is the next? 100 x12 plus 60 x13, good. Plus 30 x21, 20 x22, 35 x23. All right, subject to. What are my constraints? How about, what kind of constraints do we have? Come on. Each power plant has a capacity. They cannot send more than what's written on the left of them, right? So how about we write the constraint for power plant 1? Tell me the constraint saying that power plant 1 cannot send more than 1,250 megawatts. What is the constraint for that? X11 Yep. I cannot send more than this, so this is what's supposed to be, right? A similar constraint is to be written for the power plant 2, which is X21, 22, 23, should be less than or equal to 200. Yeah? 2,000. Correct? Okay. Do I need anything else? All Xij is greater than or equal to 0, yes, but do I need anything else? If I only write that and these capacities and solve it, I'm giving you, it's going to be 0. Don't send anything, yeah? What it says? Minimize this sum, subject to their summation shouldn't be more than this number. Yeah, 0 satisfies my constraint, yes? Yep. How? We have to satisfy the demand of each factory. Now, these constraints are called supply. Okay? We also need to be careful with the demand constraints. Otherwise, the optimum solution will say, okay, all x's are 0. Yeah? How do we do that? x11 plus x21. Yep, 1,500. Then x12 plus 22 is 750. Then x13 plus 23 is at least what? 750 again. And I have xij greater than or equal to 0. I1 to 2, j 1, 2, 3. Yeah? Sure.
Why the signs are bigger and why not it is equal sign?
Very good question. This was also valid for Monday's petroleum question too, gasoline question too. Now, yes, I have to satisfy the demand. This is a more general version of it. I'm letting my axes to take whatever values they have, all right? So as long as I'm above my demand, it's okay. Because there are 6 variables, and it may not be okay to make them all equal at the same time. In here it will be, but in the petroleum problem it will not be the case. Because we may not satisfy all constraints when they're all equality. So this is a general version of it. Equality is already there. If it is doable, the model will definitely make it equal. Okay? Any other questions? Clear? Have you written it? Because I'm switching to this part. I think we can see both, right? Can I leave it like this? All right, because I may not be able to open it again. All right, then. That was just an example, yeah? With 2, from 2 to 3. Normally, and I told you this is a simplistic case of a transportation problem because we're transporting some things from supply points to demand points. Okay? So, this kind of a problem can appear everywhere, and the general version is lots there. So we have like M warehouses, and we have N stores. Okay? They can be of anything. In the example, it was electricity, power plants, and factories. Well, it can be anything. Now, we're parameterizing everything. So AI denotes the amount of stock in my inventory. Okay. DJ denotes my demand. So in the previous case, for example, AIs were my capacities of my power plants, and DJs was the demand of the electricity in each factory. And CIJ is the cost of transportation in between. So let me go back. I'll get used to this. So these are, yeah. Okay, so these are actually, oopsie. These numbers are the supplies, right? And these numbers are the demands. And these numbers are the costs. What did we name them? AI, DJ, CIJ. So this goes as AI, this goes as DJ, and these are CIJ. So the formulation then will be, my variable is xij, all right? Amount sent from I to j. Okay? Then I'm gonna minimize. Let's look at what we have written on the right. In the general form, what we have done is actually minimize over I and j, Cij times Xij, right? That's what we have done. Subject to, this is the compact formulation. You're gonna learn how to do compact formulations too. Subject to, I have to satisfy my demand, so Xij should be at least Dj for all j. This should be summed over I. So from every warehouse, the amount I'm sending to my demand point j should be at least Dj. And I cannot send more than the capacity. This time the summation is over j. It's not seeing, but summation is over j, and I'm supposed to do this for all I. And of course, I need my non-negativity. Okay? So the one on the left is the general form for a transportation problem. We don't know the numbers, or we just name the numbers and put it like that. If we're lazy to do it like this, that is also fine. Any questions? Clear? Just keep in mind, the one on the left is called compact formulation, and the thing I have used is the parameters, right? AIs, CIJs, DJs, those are the parameters that are given to us by the environment. I cannot change, and my decision variable is Xij. So as long as you define your parameters and variables appropriately, you can always come up with the compact formulation. It's a lot neater, and it's a lot easier to go on. Any questions? That finishes one of the examples I want to discuss today. If this is all clear, I'm switching to another example. Question? There's a question? Oh, sorry, yeah. Can you raise your voice, though? Huh. No, you cannot. Uh-huh, 1500. That's what the question asked actually 10 minutes ago. It's the same question. This is more general. All right, this does contains equality, of course. So what we do is, if we write that equality, that's what we want, yeah? But in that case, we try to solve it, and we may end up with infeasibility. Not in this specific problem, this is an easier one. But if you had many constraints and you're summing some of them together and making them equality, you may not be able to find those numbers. But this, it's okay to send one more watt. I'm trying to minimize my cost anyway, as long as I satisfy my demand, okay? So for certain applications, we need to write it like that, okay? Any other questions? Good. Another version of blending. This is an interesting problem. All right. This time, we have a OJ company. The company produces orange juice. All right? Okay. We have 3 different types of oranges. And they are called poor, medium, or premium. Good. All right? Each orange type yields a different amount of orange juice. All right? So if I squeeze a kilo of grade 1, which was poor, I got 0.4 liters of orange juice. If I squeeze a kilo of grade 2 oranges, which are medium, I get half a liter of orange juice. And for good type, grade 3, for 1 kilo, I'm getting 0.6 liters of orange juice. Okay? This is one thing. So I have 3 types of oranges, and they each one yields a different amount in the final product that I want, which is orange juice. Okay. What else? Currently, in my inventory, I have 100 kilos of poor, 150 kilos of medium, and 200 kilos of good oranges in my inventory. I'm going to mix these, squeeze these, and come up with orange juice. Now, my output is also in 3 different types. I have superior, premium, and regular orange juices. Depends on how I mix these oranges, I guess. Let's see. Yep. Remember the grade numbers? 1 was for poor, 2 was medium, 3 was good. Those grades, okay, come in the left column in here. So, let me come here. So my superior, premium, regular orange juices, all right? If the average grade in the liter is 2.5 minimum, at least 2.4, I can label it as superior orange juice, okay? If I cannot make it superior, but if the average grade is 2.2, I can label it as premium. So it's, of course, anything greater than 204 is greater than 22, but I want to label it as superior if I can, because it gives me a lot more profit, right? So if the average grade is more than 2.4, the juice becomes premium. If it is between 2.2 and 2.4, I can label it as premium. And if it is between 2 and 2.2, I can label it as regular. If it is less than 2, it's rubbish. I'm not selling it. I can't use it. All right? The profits are different, as you see, 1.5, 1 and 0.75. And minimum daily production means I have to have at least that much. I can have more because depending on how I mix them, I may add up more. But minimum daily production is 45 liters for superior, 60 for premium, and 100 for regular. All right? Is the problem clear? Now I want to come up with a production plan so that my profit is maximized. Yep. Let's go back to the first page because this problem requires to observe a little bit. I have 3 different types of oranges. Each has grade numbers on it, and each yields different amounts of orange juice. So I'm going to mix these and come up with 3 different types of oranges: premium, superior, regular. All right? Depending on how I mix them, the average grade will change. Grade is 1, 2, or 3. Okay? Depending on the average in the output, I will label these as regular, premium, or superior. All right? So the question is, okay, I have this many oranges, 100, 150, and 200 kilos of grade 1, 2, 3. How I mix them? Is the problem clear? All right, then come up with a decision. I couldn't hear you.
How to calculate grades?
How to calculate? That's the average. We're going to get an average, like 2 kilos of grade 1, 2 times 1, plus 3 times 2, plus, and then we divide. Yeah, so it's the pure average. Now tell me the correct decision variable. I'm starting to write. Decision variables. This is the most crucial step in modeling. If you can define your variables correctly, you will end up with a correct model. But the variables is really, really important. First of all, how many variables do we have? Yeah? What are your variables?
Amount of oranges used from each type.
Is she correct? Can I live with 3 only? It will be too hard to formulate it with just 3 variables. Yeah. 6. What are your variables? So is it 6? He's in the right track, but do we end up with 6? Yeah. Exactly. We need 9 decision variables in the form of 3 by 3. Pour oranges to produce regular. Pour oranges to produce superior. Pour oranges to produce premium juice. Then the rest. If you define these variables like this, your formulation will be easy. So this is how I do it. This time I'm going to write it like this. I'm going to say XSI, number of kilos. Kilos of grade I oranges used to produce juice S, superior. Then I will have XPI. This is the same number of kilos of grade I to produce premium juice. And XRI, number of kilos of grade I to produce regular juice. Now, with these variables, we can deal with all the related systems requirements that's written on the left part of the board. this is an easier way to go for the final. So my variables, I have 9 variables because I goes from 1 to 3. Great, poor, medium, good. And I have superior, premium, regular, orange juice. All right? I'll wait until you write the variables because I need my board. Okay. What do I want to do? What is my objective function? This is what I'm going to do. I'm going to leave objective function for a while. I'll start from subjective first. Because for the objective function, first we have to figure out how much we're actually producing. Yeah? So with these variable definitions, so let's try to come up with the liters of superior orange juice we're producing. So the variables are xs sub I. xs1, xs2, xs3 are the variables we use to produce superior oranges. So can you tell me the equation saying that I'm producing at least 45 liters of superior orange juice? So I told you 45, you're going to need this page. Okay, let me walk you through it again. We're you're done? Can you come up? Okay, tell me. S1. Yep, let me write it and then we're going to discuss. So you tell me take 0.4 times xs1 plus 0.5 times xs2 plus 0.6 times xs3 is at least 45. Think about it. I defined my variable so that my life is easy in here, right? I defined the variable saying that S1 represents the grade 1 oranges I pick and put them in my superior batch. And S2 represents my grade 2 oranges I picked and put in my superior batch, right? And S3 is the grade 3 oranges I put in my superior batch. And how is it gone? Now for each kilo of grade 1, I'm getting 0.4 liters. For each kilo of grade 2, I'm getting 0.5. So their sum should be at least 45 liters, right? Is this right for everybody? Are you all okay with this? All right, then let's write the thingy for premium. No, medium. So the same percentages actually. Premium for 1, 0.5x premium 2, 0.6x premium 3 should be at least what? 60. And 0.4x regular 1, 0.5x regular 2, 0.6x regular 3, at least 100. Yeah? Now, can you tell me the objective function now then? What am I going to multiply 1.5 with? Yes? Exactly. 1.5 is the profit I get from each liters of superior orange juice I'm selling. So what is the liters of superior orange juice I'm selling? It's this sum, 0.4 S1, 0.5 S2, and that's it, right? Because that's the superior orange juice I have in my hand. So it's going to be 0.4 x S1, 0.5 x S2, plus 0.6 s S3, plus 1 times 0.4x P1, 0.5x P2, plus 0.6x P3, plus 0.75 0.4x regular 1, 0.5x regular 2, 0.6x regular 3. That is my objective function, yeah? Are you all with me up until here? Okay. But we're not done yet. Yeah, are we? By the way. Yes? Yep. We have to teach the model how a liter becomes superior, right? It's not just we define it, because there's a restriction there. The average grade should be at least 2.4. For the things I labeled as superior, for the oranges I labeled as superior, I mixed, right? I mixed poor, medium, and good oranges with some portions, with the variables S1, S2, S3, yeah? And then I'm saying that this is superior. I can only say it if the average grade in that mixture is at least 2.4. Got it? Let me rephrase what I said. I defined my variables like, okay, these poor oranges is gonna go to superior batch. These medium oranges is gonna go to superior batch. And this good orange is gonna go to superior batch. So I have a batch in here, I'm declaring as the superior batch. So it's like 0.4 times XS1, 0.5, blah, blah, yeah? Now this batch, this juice, can only be labeled as superior if the average of the grades of the oranges I put in here, the raw materials, right? I put good, medium, bad. If it's all bad, the average grade is 1. It cannot even be regular, forget about being superior, yeah? So I have to make sure that the average of the grades of the oranges I put in this batch is at least 2.4, so that it becomes superior.
Yes, definitely right. So keeping that into consideration, we can also write the equation for minimum average grade in terms of equation so that everything is consistent with it.
Can you do that? Have you tried it in your notes? Did you? Try to say it to me then, but I'm not going to write it in here because in liters it's going to be a mess. Is it? But the grade is coming from the kilos, from the original oranges, not the output. So that's why I said I put them in, I'm going to mix these oranges in here. As long as the average, because the grade is, the grades are labeled to kilos of oranges, not to the juice. So if you think about in terms of liters, I don't think it would go to a neat explanation, a constraint in here. Yeah?
1x S1 plus 2x S2 plus 3x S3 divided by x S1 plus x S2 plus x S3.
Exactly. That's the basic weighted average, right? 3 times XS3. XS3 is the kilos I'm putting in the superior juice from grade 3. So any kilos of orange from that will bring me a 3 in the average. Plus 2 times XS2. Anything from grade 2 will give me 2. Plus 1 times XS1. Anything in grade 1 will bring a 1. Divided by everything I'm putting in here. That's the whole kilos. Should be at least 2.4. It is a 4. Okay? This is the average. Yeah? For each kilo of the superior orange I put in there, I'm getting 3. For good orange. For each normal, what was its name? medium orange, I'm getting a 2. And for our poor orange, I'm getting a 1. And this is the average then, average grade of the mixture I put in here to label as superior. As long as this condition is satisfied, my thingy will be superior, right? Clear? Now this doesn't look like as if it was linear. I told you, remember, very beginning, additionality and divisibility and certainty. So we have to have linear functions. Even though this does not look linear, it is, because this is equal to 3x s3 plus 2x s2 plus x1 is at least 2.5x s3, 2.5x s2, 2.54x s1. And this is equivalent to, let's do the syntax and write it in the correct form, 0.6x s3. I'm subtracting, so minus 4x s2 minus 1.4x s1 is at least 0, right? If I write it like that, both the second line and the third line is okay in terms of linear formulation, all right? The one on top, you need to play with it a little bit. I mean, you cannot give them to solvers that you're going to learn as like Express or Excel. You have to convert them to the syntax that they are familiar with. And for that, that's why I did this like that. Remember, it was minimize Cx subject to Ax, greater than or equal to, less than or equal to B. I need numbers on the right-hand side. I don't need variables on the right-hand side. Just to be in the correct syntax that every solver that's been written for us to use accepts. So, yes? That's what I was actually trying to explain. Now, the average formula is the one on top, right? Okay, but that's not in the, well, when you look at it, it looks like you're dividing two linear functions to each other. So it doesn't look like linear, all right? So I'm trying to convert it to the format that the standard solvers will accept. And the one on the bottom is the format that solvers accept. I have variables on the right-hand side and just numbers, parameters on the right-hand side, all right? Is this clear for everybody? How about we write, is it finished? I don't have any more empty. Oh, hold on, I need to clean my board. So, now if you think about the constraint for premium oranges while I'm cleaning my board. What is the constraint for premium orange juice? Participation. It's 10% this time. Come on. Are you going to say it in kilos? Okay, then say it. We will have what? We will have an upper and a lower bound. Yep. So the constraint will say, let's write it in the correct form. 3x p3 plus 2x p2 plus x p1 divided by xp3, xp2, xp1 should be more than 2.2. This can go here or not. Or not. Because if I put it there, then I'm actually forcing, because if I don't have if all my oranges was very good, and if all the juices are with average grade 3, what am I gonna do? Shall I not sell regular juice? It has 100 liters of demand. So it says minimum, right? So as long as it's above 2, I'm okay. I'm allowed to label it as premium, regular, or superior. Got it? Okay, then I won't put it this here. Okay? And we're gonna write the thingy for 2. Regular 3, regular 2, regular 1, with 3, 2, and 1 divided by 3, 2, and 1. Yeah? Yes?
We don't have upper limit. Does it affect the objective function?
The objective function maximizes my profit. So if it is greater than 2.4, it will be superior anyway. It will count as them in the superior. But as I said before, if all my oranges are good, I'm mixing them, everything's grade is 3, but I can only sell 45 liters. I have to sell at least 100 liters of regular juice too. I can't label all of them as superior, then I'm infeasible from OR terminology. That's why I'm allowing it. Anything more, leftovers, will definitely go to the ones with more profit. Okay? Clear? Yes?
We label superior for averaging more than 2.4, but when we don't decide the lower bound for the inequalities, the values cannot be affected.
What are you trying to ask? What?
Yani şimdi hani biz buradaki şeyleri
I don't get your question. Now, as long as the average grade is greater than 2, it can be regular. As long as it's greater than 2.2, it can be premium. At the end, the model will select XR1s, XR2s, XR3s. Those are the decision variables. I'm writing a huge model, and I'm solving it. And at the end, the model will tell me, you know what, use 20 kilos of good oranges in superior and 1 kilo of poor oranges in superior. Then put 10 kilos in P1, you got it? So the model decides, the optimization decides how much to use where. I'm just putting the minimum requirements in there, okay? Because it has to sell 100 liters of regular too. If I'm saying that if it is less than 2.2, only then it can be regular, I may end up with infeasible solutions. Did everybody get this discussion? Because this is an important discussion. Okay, let me try to fill the whole model in here. So my decision variables are X, SI, RI, and PI. I'm maximizing 1.5 times 0.4, 1 times, and 0.75 times the thingy, subject to, I'm just putting it in, trying to put it in the correct form, 0.4 XS1, 0.5 XS2, 6 SS3, at least 45. You have 60 and 100 demand constraints. And I have 3XS3 plus 2XS2 plus XS1 minus 2.4 times XS1 plus XS2 plus XS3 at least 0. And we have the similar things with minus 2.2 greater than 0 and like that. And I have Xij non-negative. I tried to, well, my board is too small for my writing, but I just want to show you that normally you have to have all of them in the same format, in the same table. Any questions? Yes? You're right. Thank you very much. Yes. Yes. Where are they? What was it? Very good. Yeah. There's only 100 kilos of grade 1 oranges. I have one more board. Tell me the constraint. Grade 1. Yeah?
X1 plus XR1 plus what is the other?
P1.
P1. Less than or equal to
100. Yeah. Thank you. Thank you. I forgot all about it. X, S2, R2. This is an R. P2, 150. X, S3, R3, P3, 200. Okay? So the overall thingy should look like then we also have them. So we're actually maximizing profit, subject to demand, supply, and grades, and non-negativity. Okay? Clear? Question? All right. In most of the production type examples, there's always a demand and a supply. We have written the demand, but we forgot about the supply, so thanks for reminding it. So we have demand, we have supply, and we have additional restrictions, whatever it requires. Yeah? Okay, let's have a 10-minute break. We'll continue in the next hour. I'll clean my board.